Welcome to the Rutgers Cooperative Extension Compost Management School. These video presentations are designed to help you learn the principles of manure composting and the proper utilization of composted manure. In this video, we will hear from Jean Bonhotal discussing mortality composting.
I'm going to get into the nitty-gritties of mortality composting. We do a lot of work in mortality composting, butcher waste, and emergency response because we all have barns that collapse, we all have fires, we all have natural disasters, floods, and the like. So we deal with that, and then we deal with routine mortality on our farms, in our operations. It may even be, and we're doing work on this now, it may even be shelter animals. So situation, lack of services. So why are we in this situation? We're in this situation because our rendering industry can't handle the amount of material, flesh waste that we have, that we produce. Like our economy, we created a bubble. We were feeding cow flesh to cows. They don't eat meat. That's not their protein source. So we created this huge amount of market in the rendering industry, and then all of a sudden the bubble was shot. And we couldn't sell the meat that way. So that was banned. The feeding of beef to poultry was also strongly suggested against. I don't know that it's really banned at this point, but strongly suggested against. So those things affected things, plus our whole world markets. There were other reasons. There were BSE, mad cow disease. Those things got us all thinking about rendering and where those products go and who's eating them and all that kind of stuff. So there were a lot of different things that precipitated, and the beginning of that was probably 10 years ago. So specified risk materials. Next thing. So what are specified risk materials? That's the things that can give us or infect us with BSE. We think. I mean, this is all theory because we don't know how mad cow is really transmitted, why it's transmitted the way it is. There's a lot of unknowns there, and the research is extremely expensive. So the answers are really not there for that kind of stuff. But USDA said we need to remove, so if you're disposing of a cow, we need to remove the brain stem, lymph nodes, tongue, all of those parts of the animal because they have the potential to spread disease. So that's what your specified risk materials are. And if you can imagine, I just lost my cow or my horse. Now I'm going to cut the head off. I'm going to put that someplace. I'm going to put the body another place. It's just messy, not very practical. So we needed a way to deal with the whole animal in that case. And butchers have to deal with the same thing, but they're already cutting up animals. Cost. We used to get paid to give our animals to the rendering industry, and now we pay to have the rendering industry come and pick up our animals. Access. Everybody didn't have access and still doesn't have access. If you're too far away, if you don't have enough animals at the right time, then nobody's going to come pick up for you. So if you have that available. How many renderers are still working in New Jersey? 2. Yeah, in New York we probably have about the same. We've lost a lot of that capacity. Disposal options. We can incinerate, but that causes air pollution problems. We can landfill. That causes, most landfills don't want the flesh waste because the animals, if they're whole, they'll float, and they also attract varmints to the landfills, so, and cause odor. So alkaline digestion's another one, but the closest alkaline digester, and that's a chemical digester for serious disease issues, is in, well, now we have one at Cornell because they wouldn't let us replace our incinerator. But the closest one after that is Iowa. So they really aren't, they are few and far between. And if needed, they are used and the animals are transported to those, but not practical. Mass burial. When we bury massive amounts of animals, we're going to bring them 6 feet closer to the water table in a high concentration. We don't really want to do that. 100 years ago, there was a disease outbreak in pigs. The pigs were all disposed of. They were all buried, and $1 million home was built on top of that property after the farm was sold. And when they drilled the well, they were pulling up spores of the disease that was buried there. 100 years later, those things don't go away. Diseases sporulate and they can stay in the soils for long periods of time, things like anthrax, bubonic plague, all those things. So when we put them down there, they're going to stay down there in some form. Incineration is air pollution issues. We'll talk mostly about composting today. But if we have a disaster, we need to consider all of these options because we won't be able to use just one of them and take care of our issues. If we have 10,000, 100,000 animals that have to be killed because of disease issues, we have to deal with that with many different tools. Risk. If an animal is exhibiting neurological disease symptoms, then we want to call the vet. We want the vet to know about it. The vet will deal with it. You won't have to pay for the disposal. There were some cows and they were doing circles. And they thought this was when, there was a lot of news about mad cow. And so the vet was called and it ended up being listeria, a treatable listeria infection that caused the cows to walk in circles, and it was taken care of. It wasn't mad cow. So we need to know about these disease issues so that we can control and prevent them from spreading. We don't necessarily want to put them in a compost pile because we don't know, as I said, the research is expensive. We don't know if we're going to disable those prions. The temperatures are very high to disable those, and there may be some competition, some other organisms that are degrading those or digesting those prion protein chains, but we don't know that. First thing is going to be site selection. We want to make sure that we're in a good location to compost the animals that we're going to put in piles. We want to be away from our drinking water, our animals' drinking water, and streams and ponds, because we don't want to contaminate those if we have overland flow or if we have enough leaching into the ground, which shouldn't happen. We're going to talk about our best and worst case scenarios today. 200 feet is not a magic number. It's just a cautious number. Some people use 300 feet. What you really want to avoid doing is going to the edge of your property, setting up your mortality composting, and your neighbor's house is right on the other side. That's not fair. It's not right. It should be placed in a good place. We often tell people to shelter, put some trees around them or some kind of a visual screen, because it's nicer that way. It's not necessary, but it's nicer, and it also acts as a bio windscreen. So it'll absorb some of the odor if there is any, and there should not be any odor coming out of these piles. Okay, sometimes mortality composting is done in multi-bin systems, covered, roofed. A lot of times in the South, that's what's being done. With poultry, that's what's being done, and some with hogs. And I think that's a good thing. So we can move it, we can fill the first bin, we can allow that to go through the composting process, we can move it into the next bin, and we get some turning there if we want that. Or we can use it, fill the first one, fill the second one, fill the third one, and then use it that way. So there are different ways to do it. Do we need the cover? Do we need the roof? So that's debatable, and that's a policy issue that we have to think about. I don't believe we do need the roofs, and we'll talk about the moisture and the moisture control as I go through this. We have concrete block units that can be used, and I've seen them used horribly, and I've seen them used very well. We can be given all these, and this one was used well, but we had an NRCS one that was built, and they used it horribly, so we studied burial, and I'll show you some of the slides from that. This is another one. This is a windrow, and they used an old bunk silo here and created a whole windrow of cows, and this one is cow mortality, dairy mortality. Carbon source is very, very important. All carbon is different, and we have to remember that when we're doing this particular type of composting. So we can have wood chips, we can have shavings, we can have sawdust. All of those are different particle size, and all will act differently. When we're doing mortality composting, I prefer to have wood chips, and that's a municipal wood chip that's gone through a nice chipper. It's not very fine, but it has some fine and some coarse material. And I think that is our best material for most of our mortality composting. There are other things that replace that, and we'll talk about the other carbons that might work, but a good chunky thing. If we want to use shavings on top, that's fine. If we want to use sawdust on top or as part of an absorptive layer, that's fine. but we really want to have some good, big, chunky material, and it's our cheapest. It's what goes on the side of the road. Our cable companies produce it, our tree companies, all of those guys. And if you're good, you can go out there and wave them down and say, please drop this off at my place. I want a pile of wood chips here. Refused feed. So if we had feed refusal, that can be used, and that's oftentimes has a little bit of heat in it anyway, and that's great to start with. Spoiled silage, same thing. Chopped corn stalk. Some people that don't have access to wood chips or other things will take corn stalk and just chop them large so that they have that pore space, the proper pore space in there. Nut holes, depending on where you are. I know we get peanuts in New York and New Jersey, peanut holes. We don't produce them here, but they do come here for bedding. Partially composted material. So I have some manure compost that's pretty far along. Could I use that in part of my process? Yes, we could use that. It should go on the top, not on the base. The base is really important to keep that base really chunky. Bedded packs also work quite well. Maternity animals, animals that are on a pack works. Though straw tends to compact. It has a tube, you know, there's a little straw there, but when some weight comes onto it, it really compacts and we don't get that airflow from that tube. So the hay or straw, not best, but usable. Sometimes we'll use, if we want containment, we'll use bales to make a bin. So put your round bale, and you can push against those round bales if you have a bucket that you're pushing against. And if you like the idea of containment, then that works, especially for smaller animals. First, you want to create a compost bed. So you want that bed of material to be down. It should be 24 inches. So I'm going to talk more about a full-size 1,200-pound cow, and we'll talk about the other animals in between. So if we're creating a bed, this is a butcher operation actually right here. So they have windrows of butcher waste. They create their bed, and then when their bucket comes out and it's filled with guts and other parts, they have a place to put it. There's no place to put that down unless they plan ahead. Sometimes we will make more of a bowl shape in there so that if we have a lot of liquid, if we have a lot of blood, we'll need that bowl. We made a nice bowl there so that all the blood and guts would not be spilling out of the pile. Once liquids come out of a pile, it's really hard to get them back into a pile. So our goal is to keep them in those piles. So if I had a lot of blood, I would build this first. And I would build it to full height, and then I might add the blood depending on those feedstocks and how much liquid was in that pile already. A lot of this is not the strict science. It's not I have an exact carbon to nitrogen ratio. If I start regulating on carbon to nitrogen ratio, I'm going to be in trouble because my carbon to nitrogen ratio at the beginning is not going to be the same as it is at the end. And the only way I can give a regulator a good carbon to nitrogen ratio is to grind the whole mess. So the whole cow plus the amendment, and then send that sample away so I can tell them what it is. That's not the way we want to do mortality composting or butcher waste composting. So this is a different kind of composting. Clear signage is also important. We do a lot of roadkill composting in New York. This is deer goes here. When we place an animal, we might only get an animal every 6 months that dies. That would be our hope, but that may or may not be right. So we really want to flag where that last animal was so that we can best use the process and compost that animal and be aware of space. So we'll want to know where exactly we want to lay that animal. We want to pull it back a little bit, and then we're going to lay the animal right there and then move that sign. When we're composting, we want to lance large, baggy, whether it's a stomach or a rumen or whatever. It's important to go ahead and do something with that so that you don't have that problem. The other option is, if you really are squeamish about that, put a lot of carbon on top of it so it won't let it come out. It'll just be buried in there. This is layering butcher waste. We're in a very arid area here. Lots of good carbon on the bottom there. The layer of butcher waste, then we'll put more carbon on there, and then a layer of butcher waste again, and then a good biofilter over the whole thing. And we may be able to get 2 or 3 layers of butcher waste in that pile. It depends on whether there are bones involved or just organs or what. you know, and it really is being able to eyeball that, being able to understand what you need. You also have to, and this is exaggerated here, but we want to make sure that we have plenty of carbon on the outside. No meat should get to the outside of that pile. It always should have a good buffer on the edge, 12 to 18 to 24, depending on what kind of animals and what you're doing. Regulators are very interested to know if there's any leachate coming out of the piles, if there's, you know, if they might be able to sample it, if it goes on a plastic sheet. So they put a plastic, this is in British Columbia, Canada. So they put a plastic sheet down here, and then we created containment all the way around so that if any liquid came, this was high mountain desert, so if any liquid came out of that pile, they could test it. When we did our workshops, and we did workshops in New Jersey, 5 years ago, and when we did it here, we also used the liner. Neither location had any liquids to test. If we build these properly, we won't have leachate coming out of them. When we have small animals, we're going to layer those animals, okay? And I consider small, and it really has to do with our ability to move it to a second layer. If I could pick up a cow and put it on a second layer, I could do that. It would cause more compaction, but I could do it. With small animals, it's the same thing. How much can I pick up? And deer are about the size that we can do in layers. So 150 to 200 pounds, somewhere in there, we'll layer. And anything over that, we can compost by itself. And we sort of found that out by trials. At first, the DOT people came to us, and they're coming to our cow workshops, and they're like, well, we want to do this with our deer. And so we're, okay, we can do this. We know that the technology will work, but how? And we placed them the same way we did our cows individually, but in a windrow. And we didn't have enough carbon to nitrogen ratio there. So what we had to do was move the deer closer together so that our carbon to nitrogen ratio would work out, and we would be able to compost them. If we don't have them close enough together, they really will just dry out, and they won't end up being able to degrade. So we want to make sure we have the 2 feet underneath, a foot of material in between the layers, and then a good biofilter over top of those. This is deer, and we put those in frozen because they will melt and they will compost. If we let them melt before we put them back in, that's nasty. I don't want to deal with it. I'll put them in frozen, but I'm not going to put them in melted. Then we want to make sure that we have carbon all the way around, as we're saying. We're enveloping the animal in carbon. At first, people were putting this material on the ground. That doesn't work. We really want to have that there. Make sure we're totally covered with a high carbon material. It can be all wood chips if you have all wood chips available. If you don't, it can be other materials as we had in our carbon list back there. Just to recap, if we have a lot of liquid, we might want to put an absorptive material in there, but not necessary. But that just gives us what we've been talking about there. And make sure everything is well covered. Nothing should be sticking out. Composting is the opposite process of making silage. When we're making silage, we compact the air out of that. So we're driving on it, we're pushing it into a bunker, and we're taking the air out of it. When we're composting, we're trying to keep it as light and fluffy as possible so we can get the air to go into it. So we want the air to circulate around. In 12 to 24 hours, we're going to have heat in the middle of that pile, so the center is going to heat up if we've done this properly. And we see it before we leave the piles. When we're building, we see some temperature increase before we leave most piles. So that's going to heat up in 12 to 24 hours. We should have 120 to 150 degrees, and the heat's going to rise. When the heat rises, it's trying to bring more air inside, and this is the lazy person's way of composting. We create the situation to make the organisms work all by themselves, and then we don't have to do any work. So this really works well, especially when we don't want to smell the smells that are going to be in those piles. So our 140 degrees, nice wood chips. We should see heat coming off the piles. There always should be heat coming off our piles. Maggots don't survive 120 degrees. We don't have fly problems in composting unless we're doing it seriously wrong. I have seen people, and might be in your heads, put perforated PVC pipe underneath their piles to increase the airflow. So they'll use a more dense material, and they'll put their PVC pipes in and hope that that's going to create the air circulation. And what happens is some leachate inevitably gets into those pipes, and it becomes a beautiful breeding ground for flies. So I discourage people from using the perforated PVC pipe in this application. You'll see it in other pictures with manure compost and stuff like that later, but generally not in this one. When we're building our piles, when we're in very dry conditions, and I consider New Jersey a fairly dry place to compost. If you're building piles in the summer, your wood chips are dry, your animal's hot, all that kind of stuff and dry, you want to make sure that you're adding water to those layers. Start with wet wood chips. So if they're wet already from rain or whatever, from where they were stored, that's fine. If not, get a hose in there and make sure you get enough moisture in that pile, or as much moisture in that pile as possible in the beginning, because it's going to, the compost process, whether it's manure or animals or anything else, is working to dry that pile out. Okay, so it's circulating air around, and it's really hard to wet a pile after you've dried it. If you need to wet it, you found that you really want to get more moisture in there, then you shape your pile in different ways. You either can have a peak top, so if you have a peak top pile, that's going to shed any water that's going to fall onto it. It's not going to sink in. If you dig into that pile, you're going to get a little bit of moisture for a few inches, 6 inches maybe, but after that you're going to find fairly dry, maybe ash, maybe other things in that pile because it's working towards dryness. If you want to, you're in a fairly wet, we get a lot of rain in the Northeast. If we're in a fairly wet conditions, then we want to have maybe but we'd like to accept more moisture, then maybe a flat top is going to work best for us, so a level top. And anything that falls onto that chip maybe will soak in a little bit. If we want to entrain water, we're going to make actually a divot in the top of it. So anything that goes in, if we get a 2-inch rain in 24 hours or something like that, the maximum amount of water is going to go into that V. And we'll have time to soak in. It won't just run off. But it's really hard to re-wet piles. The time it takes, 12 to 24 hours, we're going to have heat. In the first month, it's going to look like cooked meat. And this is a full-size cow. We're talking about the process here. I'll talk about butcher waste in a minute. But with a full-size cow, it's going to look like cooked meat, a roast. In the second month, we're going to have digested meat. And in the third month, we're going to have fairly clean bones. What we're doing here, what we're creating here is a habitat for microorganisms to work. They're our workers. They're the ones that produce our heat in the pile. The temperature outside doesn't have that much to do with the temperature inside of a pile. The microorganisms are the ones that generate the heat in the pile and do all the work in the pile. It's like having 50 fifth graders in one room. You don't have to heat the room. They're giving off lots of energy and lots of heat. And that's basically what happens with a compost pile. If we facilitate a proper environment, then they'll be able to thrive in there, and they're going to create all the heat. It doesn't come from the sun. We can compost in shade, wherever, no problem. We will have a mature compost, a usable compost, in 6 to 9 months to a year. Depends on what we're composting. If it's butcher waste, we probably can get away with 6 months. If it's a full-size cow or deer, we may want to go a little bit further because our pathogen work has kind of showed us that it takes longer to get to low pathogen levels or pathogen-free when we're composting. We kill a lot of pathogens early on, and EPA has the sentinel pathogens that they always use. Those are easier to control than some of the other pathogens that we have. So we've done a lot of work on that, and DOT paid for a lot of that work because they wanted to know the answers. And what we found was we really want to, and it works really well for our cycles. There's no reason to speed up this kind of composting generally, but it works really well for our seasonal cycles in the Northeast, is to think that it's going to be in that pile for a year. If we dig into that pile or that pile is disturbed in any way, the temperature is going to go back up again, but the processing can occur without a turning cycle and give us the pathogen results that we'd like. When it comes to bones, if an animal is under 2 years of age, its bones have not calcified. So if we have young animals, those bones are going to go away really quickly. If it's over 2 years, it's just like us. It's going to be much harder bones at that point because the bones have calcified, and it takes longer for those to go away. We encourage you to go ahead and use those in your next base. So if you're doing this once in your life, then you're just going to leave that pile there and let the bones go away naturally. But if you're facilitating the process, you'll take your bucket and you'll pull that bed in, pull that pile back into a bed and use it over again. And the bones will add structure, they'll add pore space and increase the oxygen flow in that, or airflow in that pile. So we use our bones that way. In nature, rodents eat bones. That's where they get their calcium. So if we have a bone pile someplace, I'll guarantee you that they'll be eaten up. So let it sit 4 to 6 months, turn if desired. So if you want to get that extra pathogen kill, if you're in a disease situation, an avian influenza, a hoof and mouth, those kinds of diseases that we have to be sure that we've killed everything, then we want to go ahead and turn that after a time. When we do avian influenza and things like that with poultry, that would be in a barn if possible. We like to keep all the airflow out of that, not out of the pile, but the air that's in that building as much as possible, so that we're not blowing things out, we're not putting blowers on, we're not forcing air, we're not doing all those things. We're letting it happen naturally and passively. So we did some work with fecal coliform and E. coli. So these are EPA rules. There are no regulations that affect mortality composting in most places at this point. We're sort of using other rules and stuff and doing the best we can. Rules and regulations are coming so that we understand, so that we're all doing it correctly. But if it were a regulated compost, a biosolids compost, pathogen-wise, anything above this line could be used. Anything above this line can't be used. Anything below this line could be used in our backyard. So that's what regulation is telling us, okay? If it were a regulated compost. We can go a lot lower, as we're showing over here. We can get almost to well below background levels and almost to zeros over here. What's happening is it had a good amount. We used fecal material from the animals we were composting. So it was the dirtiest part of the animal. We put those in piles, and then we periodically pull samples out of those animals so that we know exactly what we're sampling. And with this, over time, we were able to kill the pathogens. Temperature in Celsius over on this side, and we start with November here, December, January. We want those, even in November, December, we want those temperatures to go up that quickly, and they do, and can. So they should, in 12 to 24 hours, we should have spikes of temperatures. This yellow one down here is the air temperature, so you can see there's vast differences in here. Air temperature inside the pile, under, over, and between the animals. We have data loggers that can give us this kind of data here. This is the temperature that we want to be above. We want to be above that for a short period of time, at least, for certain pathogens, and we are up there. When we were doing this work, we started the piles Halloween and Election Day, so late in the season. We weren't working with nature. We were starting with cold animals. It wasn't ideal. But our temperatures in some of our piles were a lot lower than we would have liked. We had temperatures of 104 as thermophilic temperatures in some of the piles in Watertown, New York. Low temperatures. And we still, even in those low temperature thermophilic temperatures, we had good pathogen kill. So we were very encouraged that, okay, we have a lot of people out here that aren't that educated in composting. Putting deer into piles, they're going to be able to do this because there's so much leeway in the process that we are able to do that. This one's going to show us a lot better what's happening in that pile. This is kind of a weird event over here, and we wouldn't have known what happened out here. This is like 9 months into the process. Anybody have any ideas? We weren't there, so we didn't know what happened either right away, but then we were able to put the picture together. The data loggers take temperatures every half hour or every hour, whatever we tell them to do. And what happened there was we had a flood. And there was a small ditch that started flashing, and it got the compost pile wet and added the moisture that it needed, and then that temperature went back up. So it wet, it went back up, it wet, and then it was fine. When we have had compost piles, and we never do the research on this, but every once in a while we have an accident where, you know, there are compost piles in floodplains because a farmer was doing something that was absolutely appropriate, and we flood, and our compost piles get flooded. When that happens, the compost pile, the windrow, is like a sponge, and it sucks in all the moisture, stays there, and then when the water recedes, it recedes with it, taking very little with it. It filters, basically filters that water and lets it go out. We were in situations where there are boulders, you know, 1,000-pound boulders going down the streams, and the compost piles stayed right where they were supposed to stay and looked like a windrow when the water receded. So we're very confident that that works quite well. Disposal of end product. So reuse the layer. We can reuse, especially a chunky wood chip, we can reuse that pile probably 3 times. So if we're short of wood chips, the bones are going to add the structure, and we're going to be able to use that much longer. Remove the large bones and land spread. We don't want to take a manure spreader, even if we're in an agricultural area. We don't want to take a manure spreader and start spreading skulls of animals around. Heads will roll. We can harvest safely on crops that are harvested above ground. So do we want to put it on strawberries? No. Do we want to put it on any human food crops? Probably not. Potatoes? But if we're harvesting corn above the ground, feed crops, then that's going to be fairly safe for us to be able to do, because those areas are tilled, any pathogens or anything are going to be tilled into the soils, and then they're going to be planted again. Could it be used in creating turf, in developing turf? Sure, because it's going to be grassed down. It's going to be underneath there. DOT in New York uses it in low public contact areas. That means the sides and the middles of the highways. And they grow grass quite well. So it's actually working quite nicely. Sometimes we'll use it in hay, on hay fields, if the timing is right in the year, in the year. A lot of times we can't, just because either it's growing and it's too active. In pastures, I don't think I'd put animal mortality composting on pastures. It's not going to affect palatability, but it's that little speck of dirt that would be the prion, and that's the reason we are sort of always thinking about, and we don't have mad cow in the United States for the most part. We do have scabies in sheep, and that's a prion disease. So we're always thinking about worst case scenario, and this is not an acceptable risk. It's a lot less risk than actually eating the meat. So we're really erring on the very conservative side when we say that. Somebody wanted to sell red-blooded compost. I said, I just don't think it's a good idea. Cautions: mind your regulation and policy. Make sure that it's okay for you to do this in the area that you're living in. And generally it is. We have a map that shows regulations all across the United States. So we've collected some of the rules and regulations for burial and composting and that kind of stuff, so that regulators, policymakers can look at other people's regulations and try to understand why they made the decisions they did, so that they can protect their human health as well. Securing carbon sources. Work ahead. Bring those carbon sources in and store them in windrows. It's okay to store them in windrows. The process will work. Reuse your carbon source for a base. Particle size is important. Make sure that your particle size is appropriate. Make sure that you cover your pile very well. Anything sticking out is going to be problematic. If the animals on the outside can smell it, then they're going to dig in. And odor. Odor is important. What you as a farmer or as a person that works in agriculture think is okay may not be okay to others. So just beware of that. Your capacity to smell odor is diminished in 20 minutes. Okay, and we don't get that back. That's why we can sneeze and why we can clear our sinuses out. But we are immune to it as farmers oftentimes. Characteristics of the leachate. So in one pile we would have 2 deer or 4 deer, and in the other pile we would have no deer. One of the reasons we did that was because pathogens are so high in wood chips. They're amazingly high. When we put the dead deer into our wood chips, the wood chips were contaminating the deer. Why is that? They're the wood chips right from the side of the road. We use them on our plants. We use them on other things. Kids might play around them. It's because animals live in the trees. They poop in the trees. Does that mean we should be afraid of them? No. We just need to wash our hands before we eat. I mean, that's our main thing. But there are a lot of pathogens in. So we use that as a control. We looked at all the leachate that was coming off of those piles. So in the first side, we have just wood chips. And then the second half of the chart, we have deer in the piles with wood chips. And we look down here, and this is worst case scenario, okay? This is on a plastic sheet. Anything that's coming off of that pile from our feet when we're building the piles and all that kind of stuff. Our BOD is a little high, and you'll see the BOD in the wood chips, the BOD in the deer. Of course, we have a little bit more in those piles, but that's from walking around on those plastics and all that kind of stuff. So that's T0. That's the first time we're building that pile. Then let's look down at the fecal coliform. Pretty high all the way across the board, okay? That's our wood chips plain. That's our wood chips with deer. And we have the same fecal coliform in there. Next one, okay, we're going to look and compare again. Our BOD, biological oxygen demand. So if this liquid went into a water body, it could affect the fish in that water body. If the BOD, the biological oxygen demand, were high enough, it would kill the fish. This is a week ahead. Okay. So this is the next rainstorm. We did it with natural rain, so it's the next rainstorm about a week to 2 weeks ahead. So we end up with our BOD is way down. So our first flush took a lot of stuff out, and then our second flush is there's a lot less for it to take out because the process is working. We have temperatures in those piles, and we have fecal coliform down here in the wood chip piles at 900, 400 to 900, and down here in the ones with the deer, we have 110,000. So still very low. When we're talking about pathogens, those become very, very low numbers. The other things that we were concerned about are nitrogen, how much nitrogen is coming off the pile. That was a really important number, and those numbers were very low. This is 4 weeks ahead. And again, our numbers, our BOD is way down. And our fecal coliform, way down. So not something we have to worry about. For this particular one, they were more concerned about nutrients, what nutrients were coming through than what pathogens were coming through. And even our total nitrogen is pretty low there. Tom Glanville did a lot of work on the same stuff, so if people are policymakers in the room, you might want to look into some of that research, but we found pretty much the same information there. They did it with different materials, so they enveloped the cows in different materials, straw, silage, and corn stalk, which are going to give you more nutrients, period, than wood chips will. So the wood chips don't add any nutrients to it. The other materials are going to add some nutrients to it. We talked about some of the problems that we can have. Poorly shaped piles. We don't want amorphous big piles. We want windrows. A windrow, if people don't understand what a windrow is, it's a long, narrow table. This is a windrow right here, and it's about 5 to 6 feet tall, or can vary in size. Piles that are too short can be a problem, and too much hay, straw, that kind of material, that can be a problem. They won't heat up. Poor placement. This was a good operation, but what they did was they put it across the road. Somebody went on vacation, and then they put it across the road, the path that people would be driving on. And that's where it started leaking down. Everything that's up in here, because we have grassed areas, and we encourage grassed areas, because we have those grassed areas, all of that is a filter strip. So we have a filter strip all around those piles. And because it's mortality composting, we're not in there all the time. We put the animal in, we leave it. We don't kill the grass around it. And that acts to absorb all of the nitrogen and phosphorus that would be coming off of those piles if we have our worst case scenarios. Number of animals to cover. This happened to be the situation where it became the area that we studied above ground burial because they used the containment wrong. And this is what we saw. There was no carbon in there, very little carbon in there, and animals were sticking out. They just dumped the animals in there. And they did have a filter strip planned into it. There were pipes that were coming out of the side of it. The material, the leachate that came out of that side of it was so high in nitrogen that it killed the whole filter strip. So this we actually studied, and we have a lot of numbers for the above ground burial there. But burial isn't a good way to go. Composting is going to give us a lot better, more environmentally conscious situation. Our contact information,